Let me explain all the three things. So first I need to explain how we prepare a state. Then I need to explain how we apply unitary, which we've already done essentially. Then I need to explain how we can do measurements. And if we can do these three things, then we can show how to simulate an arbitrary circuit consisting of. That's called stabilized object. That's what we're allowed to do. Measurements, preparation, and unitaries. So for preparation, if you want to prepare 0, you just, Z becomes the stabilizer. Because that's what ket 0 is. Okay. If you want to prepare ket 1, well then minus Z is your stabilizer. I don't know. Ket plus, you got X. Ket minus, you got minus X, and so on. If you already have a stabilizer, so if you already have, if the state is psi, stabilized by stabilizer operators S1, S2, Sk, and you prepare 0. So let's say you have psi tensor 0. Just if you put in the last qubit, for example, the new stabilizers are going to be S1 tensor the identity, S2 tensor the identity, Sk tensor the identity, and finally the identity tensor Z. Right, so I kept all the old stabilizers, just putting the identity in the last coordinate, and I added one new stabilizer that's the identity except in the last coordinate, or Z. And so these operators now determine this state. Right, so now I can prepare arbitrary states. For example, here I've prepared 0, plus 1, minus, and so these are the 4 stabilizers that these are 4 stabilizers that stabilize the state. So the first one is, so Z on the first qubit gives you 0, X on the second qubit gives you plus, minus Z gives you 1, minus X gives you minus. So instead of writing down this state, you write down these 4 stabilizers. That's not much of a simplification because this is a tensor product state. But this is like the first step. Okay, now it becomes interesting is when you apply Clifford's, which we've already said. So when you apply Clifford, the stabilizers are conjugated by the Clifford, like here. So, no, not like that. Like this. The stabilizer is conjugated by the Clifford, so you get another Pauli operator. And that's true for all of them. So here's an example. This is sort of what you did on. This is getting close to